What is up, guys? Welcome to a brand new video. It's a beautiful morning out here, and today we are going to do something really exciting. We are going to take a look at how players learn to take free kicks in real life, and then we are going to go ahead and implement the same learning technique for our AI algorithm. So, a few months ago, when I started my YouTube channel, I posted a video about an AI bot that learns to play FIFA using supervised learning technique. However, as so many of you pointed out in the comment section, humans don't usually learn simply by imitation, but rather by trial and error. So what we are going to do today is implement an algorithm that learns from interacting with the environment, which basically takes a lots of free kicks and learns based off its interaction with the game. You asked for it, so let's take a look. So we are going to go ahead and implement something known as reinforcement learning technique in order to teach our AI algorithm how to take free kicks in FIFA 18. The way players actually learn in real life to take free kicks is by setting themselves a target and then practicing over and over again. Now, every time they take a free kick, they actually observe the outcome of their interaction with the environment, which in this case is whether the ball ended up in the back of the net or not. If the player was unable to convert his attempt into a goal, he would actually go ahead and rework his technique, make a few minor adjustments, and then take the free kick again. This process continues until the player is satisfied with his technique. Let us try to implement this in FIFA. For the purpose of this project, I'll be using the free kick practice mode of the game under skill games. An important reason why I chose this mode is because reinforcement learning requires us to identify the outcome of our interaction with the game environment, which we can obtain using this performance meter, which is only available in the practice mode. Let's take a look at the setup of our AI bot. We will keep our game running in a full screen window. Next, we'll take a screenshot of this window using Python and feed it to a CNN feature extractor. This is the same neural net used in my original FIFA bot video, which was trained to detect the players, the goal, and the ball. The feature map extracted from this will represent the current state of our game environment. Then, we will train a dense neural network that will take this state as input and decide what action to take. This network is the brain of this bot that learns how to take free kicks. It will take one of three actions: move left, move right, or shoot the ball. Once we take an action to interact with the game, we will observe its outcome from the performance meter. Using OCR, we are able to parse and feed this information back to our neural network. It will adjust its policy based on thousands of such interactions with the game, and observing this feedback, it will learn over time. We expect the bot to perform better during this training process after a few thousand epochs. At the start of the training process, we do more of exploration, which means we take a lot of random actions in order to try different things in our interaction with the environment. This helps our model to collect varied training samples and learn different scenarios. But as we start learning things, we reduce exploration and do more of exploitation. This means that we follow the action as decided by our model's policy instead of performing random actions. This allows us to monitor what our model is learning over time. I trained it for 1,000 epochs and recorded how many goals it scored per attempt. The results show that the average number of goals scored per attempt increases from 0.3 to 0.5 during training. Note that the average is recorded over a sliding window of 200 epochs. Towards the end, the model reaches 0.5, which means it is able to convert 50% of its attempts into a goal, which I think is pretty good given how difficult the task is. However, it does fall short of attaining human level performance, since I myself am able to convert about 80% attempts in this training mode. In terms of in-game performance, the bot mostly works well in cases where there are no player cutouts obstructing the goal and converts most of these attempts very easily. It struggles when there is a wall, giving quite mixed results. When it scores, it looks great, but other times when it gets confused, it behaves really funny. On some occasions, when it is in, say, state 1, it presses right to go to state 2, and then it presses left to go back to state 1. It ends up in a never-ending loop, making me feel reinforcement learning may not be the perfect way to approach this task. So far, I have tried two techniques, supervised learning and reinforcement learning, for training game bots, and both have had their advantages and disadvantages. Maybe a combination of the two might be the best approach for this. Something for me to try out in the future. That's all for this video. Thanks for watching. As always, if you like the video, please leave a thumbs up and subscribe to my channel. Now, while I head back home, why don't you take a look at the code and try to implement it for yourself? I'll leave the link to the code in the description down below. Thanks for watching, and I'll see you in the next one.